Hey guys, okay, happy Friday. Finally, we are here. So thank God, because I've been running out of graph practices for you to find. But today we're going to take proportional tables or non-proportional tables and turn them into graphs so you can hopefully, and I know it's kind of hard virtually, but hopefully you can spot the different things that make a graph proportional without me handing it to you right off the bat. So I was able to have my kids in my second hour, they guessed it. So that's kind of cool. Okay, let me get this up and running here. So I've got two proportional tables we're going to graph and two non-proportional tables that we're going to graph. And I could have you take a minute to prove to yourself that this is a proportional table. You could create the ratios, you could find the common multiplier, but I don't think that that's really worth our time. So I'm going to go ahead and graph these points pretty quickly. 0, 0. 1, 2, 2, 4, and 3, 6. Now, something that's really important to me whenever you're graphing a line is using a straight edge, okay? Some requirements I have for you. You're going to draw all the way through the graph, okay? Don't just connect your points. You're also going to put little arrows on the end to show or signify that this graph is extending infinitely into space. These are just the points on the table I had you graph. Doesn't mean there aren't more that fall on that line. The graph is also, I cut it off at 7 or -7, but it could be bigger and there could be more dots on that line. So just always make sure you're drawing it all the way through and with the arrows, okay? Let me go ahead and draw the other one. -1, -1, 1, 1, 3, 3, 5, 5. Okay. Beautiful. Now, this is the time where I asked my second hour. I said, hey, we've been working a lot this year on when I give you something, asking you, how is it the same? How is it different? What doesn't belong? I've been really trying to get you guys to use your creative side when it comes to the math. So for this, be a great time after I ask the question to pause and see if you can think of this yourself. What are some things that both of these graphs have in common? And that's how my second hour actually figured out how to determine if a graph is proportional. So try and pause the video and ask yourself, what do they have in common? Pause. Okay, hopefully you paused. So some things my second hour came up with is that they are both straight lines, that they both the majority of their dots are in that first quadrant. I thought that was really cool to notice. That's just a coincidence, but some of my kids said that they both extend different directions. True. And the one I had to say, this clue to get the second one, what is a point that both of these graphs go through? And that's when a lot of kids came up with the origin, 0, 0. So this one is actually visible on the table itself, right? But this one, while it's not on the table, still does cross that point 0, 0. So there are two requirements that a graph needs in order to be proportional, because eventually I'm not even going to give you a table. I'm just going to say, here's a graph. Is it proportional? And if it is a straight line and crosses the origin, it is considered a proportional graph. That's it. Two things. Crosses the origin and straight lines. Okay. It doesn't matter if it's super steep or super shallow or even facing this way. If it crosses through 0 and is straight, you're good. When I put this on our digital notebook, you're going to see I have this super cute little checklist here, all fancy. I'll probably post this one instead. I also, you'll see I made the kids last year show me that it was a proportional table by making the ratio, which is kind of extra. You'll see on there, okay? Now on the flip side, these graphs are non-proportional. So when I graph these, I should see that it's not a straight line or that it does not cross the origin. Oh my God, my hair is in the bottom. Oh, here we go. Now your non-proportionals, it doesn't have to be both of these, just one. All it needs is one. It could have both of those factors to show no, but if it's not straight, doesn't matter about the origin. If it doesn't cross through zero, don't care if it's curved or straight, okay? All right, I'm gonna graph these right here. 0, 1, 1, 3.5, 2, 5, 3, 7. Okay. So when I grab my protractor, they do look pretty straight. But when I put my protractor on there, I can see it's definitely not, they're not lining up. Now, even when I draw my line, because my lead line is pretty thick, it almost looks like they line up. But I know that they have to be right on that line or it's not proportional. So not only is it not straight, I'm gonna color code this, why would I not? Not only is it not straight as a reason, but it also doesn't cross through the origin. Okay. Go. All right, last one. -1, -1, 0, 1, 1, 3, and 3, 7. So for this one, I actually made it where they do fall in line, but they don't cross through the origin. So that's the only reason for this particular one. Now, literally, if I gave you a graph and I just showed you something like this on a warm-up and said, is it proportional? Really, I want you to look for 0, 0 first. If it's a straight line, usually your eye can see that real quick. But 0, 0, right? Those are your only two items you have to look for. Okay. All right, so let me stop sharing here. So on your coach for today, I would like you're going to bounce into Khan Academy and it's 4 questions. There's going to be a few different graphs on one coordinate plane and it asks you which one, if any, are proportional. So it should be hopefully pretty quick to identify. There's really not something, I could have started something else today, but I want to really kind of slow it down. I'm going to have a few more proportional graphs or non-proportional graphs for us to look at together and you guys will just get some participation. I'm going to kind of combine a couple of weeks of participation here, but it's gonna be a real quick meeting today, proportional or not. The choice is not yours. It's a mathematical choice. Just saying. All right, see you soon. Am I still recording? Oh, cool. Blooper.